What if I told you the world's most powerful energy source is currently invisible? We've spent billions on 50,000 megadams that are now ecological catastrophes, releasing massive amounts of methane, a gas 80 times more potent than CO2. But the secret isn't just the power, it's the lack of destruction. We've developed invisible vortex turbines that use the water's own kinetic energy as it flows naturally. Instead of fighting nature with concrete, we are finally working with the river's natural rhythm. By 2030, every major river artery could function as a continuous, invisible power plant.
Longest time when we thought of hydropower, we pictured one thing, these colossal concrete walls holding back nature. Well, that era is coming to an end. Right now, there's a new revolution happening. And the crazy part is, it's completely invisible. It's harnessing the power of our rivers without a single dam in sight. Let's dive into how this invisible revolution is completely reshaping our energy future. And look, this isn't some far-off prediction. It's the reality of a massive technological shift that's happening right now. We're moving away from that brute force approach towards a smarter, much more elegant way of generating power. The age of the concrete giants, well, it's giving way to something far more subtle and, honestly, way more powerful. All right, so here's our game plan for this explainer. First, we're going to look at exactly why these megadams are failing. Then, we'll pull back the curtain on this new invisible technology. We'll see how it works with nature, not against it, how it's shaking up our entire energy grid, and finally, we'll ask the big question: what does this all mean for the future of energy? For over a century, these megadams, man, they were symbols of progress, right? But the thing is, the world's 50,000 dams are facing a huge crisis. They're quickly turning from assets into massive liabilities, and for some pretty critical reasons. Just take a look at the iconic Hoover Dam. It has lost nearly a third of its power output. You've probably seen pictures of that bathtub ring around the reservoir. Well, that's not just a sign of drought. It's a huge warning sign. If the water level drops just another 100 feet, it will stop producing power. Period. But here's the crazy part. It's not just about a lack of water. It's also about too much sediment. They call it the bathtub effect, and it's basically a silent killer for dams. Over decades, silt and sand build up, literally filling the reservoir from the bottom up. This chokes the dam's ability to hold water and generate electricity, creating this hidden and very expensive maintenance nightmare. And beyond all the engineering problems, there is an immense human cost. The history of these projects is filled with stories of entire communities being displaced on a staggering scale. The Three Gorges Dam in China, that's the most extreme example. It forced over 1.4 million people from their homes. And here's the real shocker. Megadams aren't nearly as green as we've been led to believe. See, when you flood that much land to create a reservoir, all the trees and vegetation underneath start to rot. And that process releases massive amounts of methane. That gas is 80 times more potent than carbon dioxide, which means many large dams are actually significant contributors to greenhouse gas emissions. So here's the bottom line. The old model is broken. It's inefficient, it's destructive, and it turns out it's surprisingly dirty. Which leads us, of course, to the big question. What comes next? Well, the alternative is to completely flip the script. Stop fighting the river and start working with it. And this is where the whole concept of the invisible vortex comes in. It's a new generation of technology that generates power silently, right beneath the surface. This technology is really an evolution of what's known as run-of-river hydropower. So instead of building a giant wall to create artificial pressure and water flow, it harnesses the natural kinetic energy that's already there in a flowing river. No massive dam, no giant reservoir needed. The real breakthrough here is something called biomimetic design, which is just a fancy way of saying engineering that mimics nature. Instead of those high-speed, churning blades, these are low RPM modular spirals that efficiently capture energy from the current, even in really slow-moving water. And because a river flows constantly, they provide a steady, reliable source of power 24/7. This is exactly why people are calling it a giant battery that never needs a recharge. Think about it. Solar and wind, they're intermittent, right? The sun sets, the wind stops. But the flow of a river, that provides a constant 24/7 base load of electricity. The sun-driven water cycle does all the recharging for us, which makes this technology incredibly reliable. You know, this approach completely changes our relationship with the environment. The real secret here isn't just the power this technology generates, it's the destruction it avoids. I mean, just look at the contrast between old and new hydro. It's night and day. Old dams block fish from migrating, they release methane, and they require this gargantuan infrastructure. The new model? It lets fish pass right through unharmed, has zero emissions, and uses these small modular arrays that just blend right into the river. So, to sum up the key benefits here, those fish-friendly spiral designs are a total game changer for ecosystems. By getting rid of the stagnant reservoirs, you completely stop methane production. And most importantly, you don't disrupt the river's natural rhythm, which is just vital for everything living downstream. This nature-first approach also kicks off a radical disruption of our energy system. We're talking about a move away from those massive, centralized power plants towards something far more flexible and resilient. Okay, think about this for a second, because this number is wild. In the US alone, there are over 90,000 dams, but a staggering 97% of them don't produce a single watt of electricity. Can you imagine the untapped potential if we could just drop these modular turbines into that existing infrastructure without building anything new? And that's the real beauty of it. For remote communities or even entire developing nations, this becomes a plug-and-play solution. You don't need decades of construction and a multi-billion-dollar budget. You just need a flowing river. The strategic advantages are just huge. We can create hyper-local microgrids. We can deploy them in weeks, not decades. We can empower regions that have been totally left behind by the traditional energy model. And it even makes the grid more resilient to conflict, since you're not hoarding water upstream. So where is this all heading? Well, we're looking at a near future where every major river could become a continuous, invisible power plant. And that could, potentially, lead to the end of energy scarcity as we know it.
And this isn't science fiction, this is happening right now. There is already $127 billion being invested globally to modernize our hydropower infrastructure, with a huge focus on these more efficient and less destructive technologies.
Now, let's talk about the cost. Right now, the upfront cost of invisible hydro is a little higher, but look at the projection. As it scales, the cost per kilowatt hour is projected to drop below both wind and solar. Why? Well, it's pretty simple. The fuel, that constant flow of water, is completely free. When you look at the whole timeline, you see this isn't about replacing hydropower. It's about perfecting it. We started with small-scale hydro way back in 1882. Then we went to the absolute extreme with mega dams in the 20th century. And now we're coming full circle to a smarter, sustainable model that could finally lead to true energy independence. Which brings us to our final question. With its ability to provide constant, clean, baseload power without all the ecological destruction of the past, could this be it? Could this be the missing link we've been searching for to finally achieve a fully renewable grid? The future of energy, it seems, is flowing right beneath our feet.